Europlanet IDIS teams have developed an access protocol to planetary science data named EPN-TAP, which means Europlanet Table Access Protocol. You'll visualize examples of what can be performed with this protocol and a data service called AMDA, Automated Multi-Data Set Analysis Service, through the present science case, Auroral processes. Polar aurora are the bright lights that can generally be seen on Earth in the night sky at high latitudes. They originate from the interaction between the plasma ejected by the Sun, the solar wind, and the upper terrestrial atmosphere. Aurora have been discovered on Mars, another telluric planet, and on giant planets Jupiter, Saturn, Uranus, and Neptune. We will focus on Saturn. The so-called Cronian aurora are the topic of the present science case. We start this study with AMDA, a web service developed by the Plasma Physics Data Center, CDPP. It is dedicated to the analysis of space observations in the domain of plasma physics. Firstly, we'll use AMDA to investigate auroral events on Saturn. We know that auroral events occurred in January 2004. Consequently, we'll look for interplanetary disturbances in the vicinity of Saturn that could have initiated auroral phenomena during this period. To do that, we'll display the magnetic field recorded along the trajectory of this Cassini spacecraft around Saturn. Data are available in the CDPP database, and can be plotted simply by dragging the parameters of interest to the plotting window, meanwhile indicating the time interval of interest to us, namely between the 13th of January 2004 and the 31st of January 2004. Once the time interval is chosen, we click on Plot to obtain the magnetic field profile along Cassini's trajectory. On the plot, you can see some local magnetic field disturbances between the 15th and 18th of January 2004, when the spacecraft is upstream of Saturn's magnetosphere, in the solar wind. We suspect that such disturbances can induce auroral phenomena on the planet. We are able now to retrieve and visualize Hubble Space Telescope images of Saturn during the same period, thanks to EPN-TAP and a VO protocol called VO-SAMP, the Simple Application Messaging Protocol, and verify if observed magnetic field perturbations have triggered aurora on Saturn. With EPN-TAP, we can directly query from AMDA the Auroral Planetary Imaging and Spectroscopy Service, APIS, at Observatoire de Paris, about HST auroral images corresponding to the selected period. We firstly connect to the SAMP hub. Then, still from AMDA, in the APIS archive window, we can refine the interval time between January the 15th and 25th. By clicking on Refresh, we see the answer from APIS. Some images are available. We can see a preview of each of them, and we note that they indeed show auroral lights on Saturn's pole. Without EPN-TAP, we would have to connect to APIS and manually select the target, the telescope, the observation type, and the time interval of interest. We select original images from January the 16th, 18th, 20th, and 21st. Using SAMP, we can now transfer the selected images to the VO tool Aladdin and visualize them all together on a mosaic. We can see that aurora characteristics differ from day to day. This highlights the dynamic nature of Saturn's aurora. Now we'll look for HST spectral images of Saturn's aurora, and we'll try to perform spectral analysis using VO tools. A spectral image has the wavelengths on the x-axis and the vertical direction on the y. To begin that exercise, we query Europlanet client. The query options are as follows. The target name is Saturn, and the data type is spectrum. The same query is sent to all services. A positive answer returns from APIS. We click on Display Results to display the catalogue. In the Show Hide menu, we choose to display the instrument host corresponding to the data, and we verify that it's HST. Previews of spectral images appear on the right-hand side of the screen. Once spectral images are found, we'll analyze one of them using SpecView, a 2D spectral visualization and analysis tool for astronomical spectrograms. It is available for download on this web page. We start SpecView, select one of the spectral images, and send the data to the VO tool thanks to the SAMP protocol. With the client SpecView, we open a spectrum corresponding to the sum of all vertical spectra which make up the spectral image. The spectral lines corresponding to the light emitted during aurora events depend on the composition of the atmosphere which the magnetospheric particles interact with. Saturn's atmosphere is principally composed of hydrogen, and the Lyman alpha spectral line is a transition line of atomic hydrogen, located in the ultraviolet part of the electromagnetic spectrum. The corresponding wavelength is about 1216 angstroms. We can see that the plotted spectrum extends from about 1100 to 1700 angstroms, and we presume that this line corresponds to the Lyman alpha transition. We'll attempt to automatically identify this spectral line on the present spectrum using the SpecView line identification tool, named Line IDs. By clicking on the Line IDs button, the line identification tool shows up on screen. To access information about transition lines, we have the possibility of querying a large panel of atomic and molecular data services. We choose to query only one of them, Chianti, the atomic database for spectroscopic diagnostics of astrophysical plasmas. The present query is, give me all line lists you have in the same wavelength range as the present spectrum. Chianti returns a number of spectral lines and, among them, the Lyman alpha line. We can draw this line on the spectrum. The observed shift between theoretical and observed lines is due to a bad wavelength calibration of the HST spectrum used. On APIS, we can retrieve higher-level, calibrated spectra for the same observation. As has been done previously, we draw the Lyman alpha line on the calibrated spectrum, and we see that it's now at the right place. Line identification can be used further to search for the radiating atmospheric species, such as molecular hydrogen. So finally, we see that it's possible to link different aspects of auroral processes, magnetic field, imaging, and spectroscopy, in a simple way using tools of the virtual observatory applied to planetary data made accessible by the AMDA web service and the Europlanet Table Access Protocol. Thank you for your attention.